Hello everybody, welcome back to another episode of Math with Mr. Emond. Today we are going to be continuing on in our unit on systems of equations. In this lesson, we're going to be actually solving systems of quadratic-quadratic equations graphically. So let's get started with that. We're being asked to graph these two equations. They are both quadratic equations, and we know that because of the x squared terms here. So let's get started with this. The first thing that we're going to have to do is actually isolate our y. So we're going to add y to both sides on this top one, and we're going to add 35 to both sides, just to move things around a little bit. And when you do that, you're going to have y equals 2x squared minus 16x plus 35. All right, on this next one, we're going to apply a similar strategy, add y to both sides and add 11 to both sides to get rid of these things. And that's going to give us y equals 2x squared minus 8x plus 11. All right, now that we have these things isolated, we can go ahead and try to start graphing them. Now, they don't look like they're very useful as they stand right now. So what we're going to do is we're going to determine the vertex form equation of them. Let's start with the one in red. So I'm going to use standard completing the square for this one. So I'm going to isolate my first two terms and factor out a 2 because I can see both of these terms have a factor of 2. So that's going to leave me with x squared minus 4x. And when I said isolate the first two terms, I mean put them in parentheses like I did here. And the plus 11's on the outside. Now I'm going to continue completing my square. So I'm going to have to take the b value of this, so negative 4, divided by 2 is negative 2. Negative 2 squared is plus 4. So I'm adding 4 on the inside, which means I need to subtract 4 on the outside. But remember that there's a 2 here. So rather than doing minus 4 on the outside, I need to multiply that by the 2. So it's going to be minus 8. And of course, there's still this plus 11 there. And so that's going to remain. Now we're getting close to vertex form. This is a perfect square. It's x minus 2 squared. And negative 8 plus 11 is plus 3. So there we go. We're in vertex form. That's completing the square. Let's do a different method for the second one. We're going to start by looking at this. So our a value is 2. Okay, so for our p value, we're going to do negative b over 2a. So that's going to be negative 16 is our b value over 2, and our a value is, of course, 2. Now, negative 16 is just 16. 2 times 2 is 4. 16 over 4 is 4. So our p value is 4. I'm just going to clear up some room. I don't want to be using too much of it. Our p value is 4. Now, for our q value, we actually need to plug in that value of 4 into our function here. So let's go ahead and do that. 2, and then we are going to plug in 4 for our x squared minus 16, plug in 4 plus 35. 4 squared is 16, so this is 2 times 16. 16 times 4 is 64, so that's minus 64 plus 35. 2 times 16 is 32. Minus 64 plus 35. 32 minus 64 is negative 32. Plus 35 is positive 3. So our q value is 3. Okay, and now we have the 3 requirements for our vertex form. So we can do y equals a x minus p squared plus q. So there we go. We have our vertex form equations for our two functions here in red. There we go. Let's go ahead and graph. So we'll do the red one first. Our vertex is 2 and 3. So there we go. It's opening up with an a value of 2. So instead of going right 1, up 1, we're going to go up 2 because your a value multiplies your normal x squared function. So that's, I know that, let me explain that a little bit more. I know that in a normal x squared function, we're going to go right 1, up 1, then right 2, up 4 on both sides, and then right 3, up 9, which would be like up here. Okay, so that's a normal x squared function. This isn't a normal x squared function because it has an a value of 2. And what that a value does is it multiplies the y stretch by 2. So rather than going up by 1, it's 1 times 2. So it's 2. And so I can erase these and draw that in. Normally it goes up 4, but now it's going to go up 8. So there you go, because 4 times 2 is 8. I'm going to erase those because they're not going to matter anymore. And of course, this one is being mirrored, so it's up there. And now we can go ahead and graph it. So we have enough information here. So there we go. And yeah, I can probably do better than that. Yeah, there we go. All right, so there's my first one. Let's go ahead and draw my second one in blue. So here my vertex is 4 and 3. So 1, 2, 3, 4, 1, 2, 3. And again, it's open up and it has an a value of 2. So just like before, it's going to be right 1, up 2, right 2, up 8. So 1, 2, 3, 4, 5, 6, 7, 8. And mirror it. So it's going to cross there and here, up 8. There. Okay. And graph. Good enough. And so we can now identify where that point of intersection is. That point of intersection is right there. And what is that point? Well, it looks to be at 1, 2, 3, and 1, 2, 3, 1, 2, 3, 4, 5, at the point 3 and 5. So we're going to verify this solution 3 and 5. And I want you to kind of ask yourself, will there ever be a point where they intersect again? Because we can see it's crossed this one. This one's going to keep going towards the right. This one will keep going towards the right, towards the left, towards the left. Will they ever meet again? And the answer is no, they're not going to ever meet again. So it's just that point there. Let's go ahead and verify our solution now. So we need to plug in our x value into the first equation. So it's 2. Our x value is 3 squared minus 16 times 3 minus our y value is 5 equals negative 35. Okay, 3 squared is 9, so that's 2 times 9, minus 16 times 3 is 48, minus 5 equals negative 35. 2 times 9 is 18. Okay, and then we have 18 minus 48 is negative 30 minus 5. And it looks to be true. Negative 35 equals negative 35. Good. Let's try our second function here. 2 times our x value is 3 squared minus 8 times 3 minus our y value of 5 equals negative 11. Let's see if this is true. This is 2 times 9 minus 24 minus 5 equals negative 11. 18 minus 24 minus 5 equals negative 11. 18 minus 24 is negative 6 minus 5 is negative 11. Is negative 11 negative 11? Yes. All right, so we verified our solution. They work for both equations, and that is it for this problem. it's going to be your turn now. Go ahead and solve this graphically. So you have these two equations, which you'll need to isolate your y and put it in a form that's going to allow you to factor. So either put it in vertex form or try to factor it to find your x-intercepts, then graph and verify your solutions in part B. When you're done, come back and check your work. See you soon. Welcome back. Let's go through the solutions here. So the first thing that you should have done is isolate your y. At this point, I'm not going to do it in two different forms. I'm just going to complete the square because it seems to be a little bit easier here. So after completing the square on the first one, I got 3 times x minus 2 squared plus 4. So at that point, I was able to start graphing. My vertex is 2 and 4, which is right there. And then I had an a value of 3, so right 1 up 3. And that's where these 2 points came from. Then we're going to try graphing the next one. So now we have this equation, and you're going to complete the square, and you get this right here. So vertex is 2 and 4 again. So there's a point of intersection, and it's open down because its a value is -4. So it's going to go right 1, down 4, mirror those points, and you can try the next one and the next one. They are way down here. And now you can graph that, and you'll see there's only one point of intersection. It's at the vertex for both of them, and that's at 2 and 4. And when you check your solution, they do both work. Excellent. All right, that's going to be it for this video. In the next video, we're going to try some modeling of our systems of equations, and it will be our last video for this section. See you soon. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.